Sir, in the last videos, I think we have seen very clearly about different types of sorting algorithms. Okay, different types of sorting algorithms we discussed in the last videos. Sir, as a part of continuation for that, we have seen predefined sort function and a predefined sorted method. Okay, next and after that, how to implement a bubble sort, how to implement a selection sort, how to implement insertion sort, we covered. Sir, still we have two more sorting techniques are there, like counting sort and radix sort, that I will explain in the later sessions. Okay, because it will confuse you. That's why as of now I'm not going to cover those two at the end of the sortings I will cover. Sir, next what is our next concept here is, so divide. Okay, the title of the topic is nothing but, so divide and conquer. Okay, divide and conquer algorithms. Sir, it is also something like sorting algorithms only. It comes under sorting algorithms only. Sir, what is this divide and conquer? Actually, it is a strategy. Okay, it is a strategy. What is that strategy? Sir, you are going to divide a big problem into small steps. Later we can solve that smaller problems, and you can combine the solution. This is the technique which we are going to use in this divide and conquer. Actually, it is a kind of a strategy. When we can apply this one is, so divide and conquer. Okay, divide and conquer is a method, so which divides a big problem. Okay, a big problem into, sir, small, okay, small sub problems. A big problem into small sub problems. And we can find a solution, for those sub problems. We can find a solution for those sub problems. And finally we can combine those solutions to get solution for the original problem. If you want to get solution for the original problem, you are going to combine the solutions of all the sub problems. So for this we have different types of algorithms are there. Sir, we are going to talk about this merge sort algorithms, then quick sort algorithm. Okay, then binary search algorithm is also implemented based on this. Of course, we have different kind of strategies are there, but we are not going to see all these things. As a part of this divide and conquer, I am going to explain how this merge sort is going to work, how this quick sort is going to work, and how we can implement this binary search. But since it is a part of sorting techniques, we will concentrate first on merge sort and then quick sort. Anyway, our next immediate topic will be searching algorithms. There I will explain how to do this searching operation. Sir, if the theoretical part is clear, directly I will go with the merge sort application. Everyone please confirm, is the theory part, is it clear? Yes, please confirm everyone. Right, sir. Now to implement this I am taking, sir, please respond. If there is no response, then it won't be good. I request everyone to please confirm. Is it clear?
Sir, how the divide and conquer is difference is means the difference between divide and conquer and dynamic programming, sir. Then what is the difference between? Because in dynamic programming also we are doing means we are dividing big problem into smaller problem with the help of recursion and
Hmm.
combining all the small problem mm, to form a means optimal solution to form a big problem.
You are telling the solution difference with your words only. You are finding the optimal solutions. Be here that things won't be there. So dynamic programming and divide and conquer are two different approaches. So even these two we can't compare. Why? Because dynamic programming is based on recursion. In the recursion, some repetition calculations will be there. To avoid that repetition calculation, we are going for dynamic programming. Okay, divide and conquer strategy is different. In the divide and conquer strategy, compulsory you have to travel from root to depth. But in the case of dynamic programming, if any repetition is there, we won't calculate. That is different, sir. Don't compare those two. Once if I cover dynamic programming, you will get clarity. Okay.
Got it. So means in divide and conquer, we can't be able to find an optimal solution.
Yes. First of all, we have only one solution by using this divide and conquer. Divide and conquer means what? Something like it is a hierarchical strategy. So if you have 100 problems are there in your hand, you can't solve 100. So try to divide in a month, first 15 days. So I'm going to solve 50 problems. Remaining 15 days, I will solve remaining 50 problems. In that 15, sir, again that 50 is divided into two parts. In 7.5 days, I'm going to solve 25 problems. In the rest of the 7.5, like that, we are planning, right? So that strategy is called as divide and conquer. Got it? Yeah, everyone please confirm. Clear? Right. Sir, to move to the merge sort application, directly we can't go for merge sort. Some examples I will cover. Example number one. What is the first example here is I'm going to divide. Okay, I'm going to divide I'm going to take one function. The name of the function is nothing but merge. Something like this I'm taking, which is taking two list objects. Okay, it is taking two list objects, and so I'm calculating concatenation of these two list objects. So L1 L2 both are concatenated, the result is available in L3, and I'm sorting this L3, and I'm going to return that list 3. This is nothing but just for top level to understand, I'm explaining this merge function. Let us take, I have a list with elements, sir, 10, 15, 20, like this we have. Again, I have another list is there with elements, so 5, 6, 7, and then 30, like this we have. Okay, I'm trying to print the list A, I'm trying to print the list B, I'm trying to print, so merge of A comma B. Have you observed, sir? I'm taking one merge sort function. This merge sort is going, not merge sort, merge function. What this merge is going to do, it is taking two list objects, and those two list objects are merged to third list. Directly I am sorting and I am returning. It is a very simple phenomena. But of course, how this merge operation is going to work internally, I will explain. But the problem here is, sir, it is not working. I think where I am doing this, so this file name is test, sorry. Now I am running, you can see 10, 15, 20, so 5, 6, 7, 30. But later those objects got added into the list, and those elements got sorted in the order. This is nothing but just I am trying to demonstrate the functionality of which one, merge function, how it is merging two list objects I am explaining. Sir, to demonstrate this, you are taking the predefined operator called plus and predefined function called sort. Can I take my own function? Yes, happily you can do. So that part I am going to demonstrate now. Sir, if you are clear with what is the functionality of merge, then I will take another example to demonstrate how you can able to implement this merge function without using these three tools, without using these two tools. Sir, is the concept is clear up to this whatever I covered? Please confirm. Sir, I request everyone to
Yes, sir.
please
Yes, sir.
respond. Clear? Right. So just give me 1 second. I will be back. Right. Sir, sorry for the delay. Let me continue. Sir, am I audible? Please confirm.
Yes, sir, you are.
Right. Now, sir, I don't want to perform this concatenation and I don't want to sort by using predefined method. Can you implement by your own? I'm taking one empty list, which is nothing but L3. So I want to find out the sizes of first list, length of L1, the size of second list, length of L2. Then what we have to do, I'm maintaining two pointers like I comma j. Sir, if you want a parallelly, I will take one diagram so that you can get clarity. So in the first list, we have 10. Okay, so 15 and then 20 is there. Okay, in the second list, we have 5. So 6, so 7, 30 is there. This is list 1 and this is list 2. What is the m value? What is the size of the list 3? What is the size of this list 4? Sir, ij, this is 0th location, first location, second. 0th location, first location, second location, third location. I is initially pointing to 0. J is initially pointing to 0. Already I created another list with name L3. Now my task is I will take the element one by one from the first list and the second list and I will compare which is the smallest. I will store that value into the list. That is my task. Sir, here I am going to take one while loop because how many elements will be there? I don't know. Until the value of I is less than m, until the value of j is less than n. Sir, what we are doing? Can you please check the element which is present in the first list is less when compared with the element present in the second list? Then what I am doing? Directly, I am appending that element to the list one. Then I is equal to I plus 1. Sir, else, if that condition is not satisfied, definitely it is greater. Means which element you have to store? L2 of j. And j will become j plus 1. Sir, how it is going to work? Please observe carefully. So what is the value of I? Initially it is a 10. Sir, j value is, sorry, initially it is 0. J value is also 0. L1 of 0. Which element is there? 10. Is it less than? L2 of j. Is it less than, sir? No. That means what? 10 is not the smallest element. Sir, 5 is the smallest element. But please make sure if you want to apply this, these two list objects must be in sorting order. Then only we can apply. Okay. Sir, is 10 is less than 5? No. That means 10 is not the biggest element. Sorry, smallest element. 5 is the smallest element. Can you please append that L2 of j into L3? Sir, 5 will be appended. Now observe carefully. J is equal to j plus 1. Now onwards, j is pointing here. This element is stored into the list. Sir, what will happen? Again, is I value is less than m? Yes. Is j value is less than n? Yes. So take L1 of I. It is nothing but a 10 only. Is it less than? So L2 of j, 6. No, sir. That means what? Else L3 dot append of, take this element and append into the list. Immediately increase the j value by 1 unit. Then I is less than, j is also less than. Again compare 10 with 7. Sir, condition is not satisfied. Means what? So 10 is the last smallest element. You have to push 7 and then j will become 3. Now compare 10 with 30. Sir, yes, condition satisfied. That means 10 is the smallest element. Then what we have to do? Don't push L2. We have to push L1. Sir, this element will be added and which value will be incremented by 1 unit? I value. Now what we are doing, since I is less than 3, j is also less than 4. So we are comparing. So 15 with which element? 30. So since 15 is less than, that 15 will be inserted here and this I value will become here. Okay. Then 20 is less than 30. Yes, condition satisfied. Then what will happen? This 20 will be inserted here. Then I will become 3. When I is equal to 3, this total loop is going to be terminated. But there is one small problem. We extracted all the elements from first list. but one element is pending in the list, second list. Can I add these elements as it is? Yes. For that, I am taking one more loop, which is nothing but until j value is less than, until j value is less than n. So try to append each and every element present in the second list. So into L3 and j is equal to j plus 1. Sir, maybe the first list also can contain elements, right? How to check that? If j I is less than m, can you please append that L1 of I value into the L3 and take I is equal to I plus 1? Like that we have. I think you people got very clear idea how you can able to store the concatenated list objects. Now you can see, sir, is I value is less than M3? Yes. So this loop won't work. Sir, is J value is less than N? Condition is satisfied. So whatever pending element is there, try to extract and put it into the list. Now your J value will become 4. This condition is also not satisfied. See, this one is for comparing and pushing. And if any leftover elements will be there in the list one, this is the loop to extract that. If any elements are there in second list, these are the things what we have. Okay, sir, I think everyone feeling comfortable up to this whatever I covered. Do you have any doubts, friends? Please confirm. Ayo, no response from your side.
No, sir,
Sir,
no
please
doubt.
confirm. Is it clear?
Yes, sir. So that is why in a recurrence relation of a mud sort, we are using one extra term apart from 2tn by 2.
Yes. Got it now?
Yes, sir. And sir,
Right.
is it necessary that list one you have taken L1 and L2 in sorted order? Is it necessary that it will be in sorted order always?
Yes, compulsory. Otherwise, this application won't work, right? So because we are taking the element from first list and we are taking the element from second list.
Then sir,
So
what?
if you no, if you are taking the first element from both list, these are the two smallest elements in both list, right?
Right. Okay.
So that one will come either first list element or second list element will come into the first position. Got it? Like that, the comparison will be done. You will
Then
get
sir,
clarity. Then
then
you yes, ask your doubt.
then sir, what will be the purpose of doing sorting?
Here
If
we didn't sorted. Where we sorted?
no, sorry, here we are appending. Yes.
Yes, just we are appending by comparing the elements. Okay. So
Yes.
how you will get know whether list 1 and list 2 are in sorting order? How you can get
Yes,
that
that
part only we are going to discuss. That is called merge sort. Got it?
got it, sir.
Okay. I will show you the diagram. You'll get clarity.
Sure.
This is the second example. If you run the file also, you will get the same output. But sir, all these things are okay. But how to define merge sort? Very simple, sir. Now we are going to see how merge sort is going to work. Listen carefully. You will get some points here. See, consider I have a list is there with me. Okay. The elements present in the list is nothing but so something like a 5. Okay. Next element is 2. Next element is 4. Next element is 1. Next element is 3 and then 6. Like this we have. Sir, please listen carefully. Now, sir, I am going to divide this list into two parts. How many elements are there? 3 plus 3. 6 elements are there. Sir, 6 by 2. What is the value? 3. What is the value? 3. Sir, what I am doing is from 0th location. Okay. From 0th location to this location, one element, one sub list, and from here to remaining next list. That means I am dividing a list into two parts like this. So whatever technique that you applied for this list, try to apply the same technique here. Here, how many elements are there? 3 elements. Sir, if you take 3 by 2, what will be your result? 1. So 0, comma 1. So I can say we will get 5, and here we are going to get 2 comma 4. This one also, sir, 1 we will get 3 comma 6. Sir, again this is divided into two parts like 2 and 4. Again this is divided into two parts like 3 and 6. Sir, you have to perform this operation until, okay, you have to do this operation until your list size will become one element. Now in all these examples, sir, are you seeing the size of the list is only one element, right? Here one element, here one element, here one, here one, here one, here one. That means what? So I got the first element as a 5, then I got a 2 and then 4. So by dividing into two parts like this, and here I have 1 is there, and here we have 3 comma 6. Do you know, we have to merge these two now. First we have to merge these two, so then we have to merge with this result. So we have to merge these two, and we have to merge this result. Have you observed, if I merge this 2 comma 4, sir, I am considering this is L1 and this is L2. Is these two lists are already in sorting order or not? Yes sir, only one element is there where sorting will come automatically. By default it will be. Now take the first element and compare with the next one, so in the list it will be added, right? Then all the elements completed in list 1. Sir, in the second list we have pending elements, so 2 comma 4 will become your result. Now combined with this is list 1, this is list 2. Take the first element 5. Sir, compare with 2. Is 5 is less than 2? No. That means what will happen? 2 will be the next element. Sir, compare 5 with 4. Since 4 is the less element, it will come. Then is there any elements to compare? No. Then copy all the elements. Have you observed? Like that we are getting. And here also 3 comma 6. So that will be combined like this and combined with 1. So what will be your result? So 136. So this is a sorted list now. This is sorted list now. Combine this. Sir, take 2 and compare with the first element. Is 2 is small? No. Then take 1. Sir, next take the next element. This one is inserted. Take 2, compare with 3. Since 2 is less than, it will come. Take the next element 4, compare with 3. Sir, is 4 is less? No. 3 will come here. Then compare 4 with 6. 4 is the less. 4 will come here. Take the 5 and compare with 6. 5 will come here. And then 6. Sir, do you know, like this it is going to work. Sir, whatever I have drawn by using red color, this entire process only, which function is going to do? Merge function. Just now I explained, right? This merge function is going to do. Sir, what about this one? For this we have to write code which is nothing but merge sort. It is a recursive process, because whatever technique you applied for this main list, same technique we are applying for the sub list. Like this we have. Sir, is the concept is clear? Please confirm.
Yes, sir.
Any doubts? So let us go for implementation of this code. So anyway, already merge function is there. Now I am going to define merge sort. Merge sort I am taking. And how it will be? Sir, I am taking a list. I am taking left index and then a right index. 2 index values I am taking. And after that, so if a right index value is greater than left index value, then only you have to calculate a middle. What is the formula? Left index plus right index double slash 2. And again this process we have to call recursively for the list by taking left index comma mid value. Again we are calling the same merge sort by passing so mid plus 1 comma right index value. Let us do this, sir. Up to this whatever I explained how it is going to work. Consider I have a list of objects are there. Okay, so like 5. Okay, next 2, next 4. Okay, next 1, next 3. Like this we have. Sir, what is the left index? What is the left index? 0, 1, 2, 3, 4. So I'm going to give this list. Left index is 0. Right index is what? 4. Sir, is 4 is greater than 0? Yes. Then calculate the mid. What will be your mid value? Low plus high. 4 plus 0. 4 by 2 means 2. So from that list, try to call again merge sort by taking the lowest index as left index as a L index, right index as a mid. What is a mid value? 2. Okay, that means what? These three elements will be separated. So which is nothing but a 5, 2 and then 4. So this is this one. What about this one? Left index, sorry, list mid plus 1. What is the mid value? 2. 2 plus 1 means 3. From third location to fourth location means what? 1 comma 3. Sir, this process will be applied again, right? Since it is a recursive call. Now here 0, 1, 2 is there and here 3 and then 4. So 0 plus 2, 2. 2 by 2 means what? We are going to get 1. That means 0 comma 1 will become one list. So then 2 will become another list. Then again this one will be divided into two parts. So this one is again divided into two parts. Like this we will get. Sir, how to combine this? Very simple. These two we have to combine just by passing merge function. Which elements you have to take? List I want to take and left index. Okay, left index I am passing and then mid value I am passing and right index. Three different values we have to pass. Sir, merge function is the same. List I have. Okay, so low value is there, mid value is there, high value is there. Based on this, we have to write the code. Just I explained the functionality, sir. Now I will write the code for that. Don't worry at all. Okay. Sir, up to this, how this merge is going to work? Is it clear for you people? Yes, please confirm. Right. So now we have to do this merge operation. Already I implemented code for that, right? Same thing, but a small changes technically. What is that change? Sir, already we are passing list 1, list 2 as externally, but here you have to extract from the main list. From which value to which value? Low to mid minus 1. Okay, sorry. Low to mid plus 1 will become the first half. Actually, it will get the data from low to mid. Okay. So because you know slice operator second argument is always excluded. And right list will become from the same list I am extracting from mid plus 1 to high plus 1 so that the second part will be exact. Now these two we have to merge, right? We know the code. I is equal to 0 I am taking, j is equal to 0 I am taking, and k is equal to what is the low value that you are passing. Now sir, while I value is less than length of the left and j value is less than length of the right, sir, what we have to do? Left side element is less than right side element or not, we have to check. If else, so if it is true, L of k will become, so L of I. We are doing copy operation. After that, I is equal to I plus 1. Previously we appended, but here we are doing manually. K is equal to k plus 1. Sir, otherwise what we have to do? In L of k, which element you have to copy? The element which is available at jth location. Then you have to increment j by 1 unit and k is as usual because k is pointing to the original array. Like that we have. Sir, next, is there any pending elements? How to check? If I is less than left array, so we have to copy L of k will become, so L of I, then I is equal to I plus 1. So after that k will become k plus 1. So while the value of j is less than right array, so L of k will become L of r. Then so not L of r, L of j. So then what we have to do? Your j will become j plus 1. Okay, your k will become k plus 1. Like this we are going to take. Sir, at last what we have to do? We need to return. No, not return because we are doing the modification on the same list. Sir, I will take a list for you to understand. I am taking a list like sir 4, 6, 1, 9. So 2, 7, 3, 8, 5, something like this. Initially, I am printing the list. Later, I am calling merge sort by passing the list 0. So what is the length of the list? -1 will become which argument? Right index. Then we are going to print that list. Sir, definitely it is going to do the modification in the same list. It won't create any new list objects. Of course, in the internally left list, right list will be created. Somewhat time complexity will be there, but definitely it is going to merge these two elements. Let us run and check. Sir, are you seeing anywhere the problem is there? Okay, something when we are merging, some problem is there. Let us identify what is that problem. Sir, here LR heavy observed, we have to copy from the small L. Okay, and the list is capital L. And here also we have to copy from small L. And here also we have to copy from small L. So here we have to copy from R. Okay, so here also we have to copy from R, because for left array is different, right array is different. Okay. That's all right. Yes. Now run the code. Sir, are you seeing this is nothing but before performing sorting operation, and after applying the merge sort, this is nothing but the result what we got. I think you people got clear clarity how this merge sort is going to work. But if you need more clarity, definitely you have to take a paper and a pen and try to execute. You will get more clarity on this. Sir, everyone feeling up to this, whatever I covered, please confirm.
Sir, can you explain it once again?
Sir,
Not the total concept,
where
but
you are,
the brief idea.
which one?
Brief idea, sir. Just come back, sir. That photo you are reading something, right? Not this. No, sir. Just
Image, huh?
yeah, sir. Image, yes.
Yes, where you have doubt in this.
Just 1 second, sir.
Sir, clear everyone, please confirm.
Sir, in dividing phase, why we are using seal value? Why not floor value?
Sir, we will use integer value, right? So 6 by 2 means we will get 3. So
Float
6,
division, float.
if you take like this, you will get 3.0. His indexes value will be floating point.
What if, sir, 3 by 2?
What if I 3 by 2? What is a 3 by 2 value?
1.5.
1 point something. But since you are using single slash, you will get, sorry, if you are using double slash, you will get 1 only. Because next index 3 point something, if you are getting 3 only, right, we will consider. See, normal, sir, if you have 10 objects are there, how to identify middle value? 10 by 2, which is nothing but 5. So if you have 9 elements, 9 by 2 means what? Around something like 4 point something. That means first 4 elements, remaining 5 elements. Like that it will be there. It will be difference for even and odd, right? Even length, odd length arrays will have difference. Clear?
Yes, sir.
Okay, sir. Okay.
Right, sir. So based on this, we have another sorting is there, which is nothing but a quick sort. Sir, what is mean by quick sort? It is also a kind of sorting technique. Sir, what is this quick sort is, for example, if you take some elements, okay, if you take some elements, maybe, sir, 5, so next and after that 6, okay, or 5, so 4, okay, next and after that 2, okay, next and after that 6, next and after that 1, and after this 3. So these are the elements what we have. So what we are expecting? We are expecting 1, 2, 3, so 4, 5, 6 like this. So by using quicksort, I want to analyze this. How to apply quicksort for this? Very simple. So total how many elements are there? 6 elements are there. Try to select the last element as one special element. That element word is nothing but a pivot element. We are using some special word called pivot. This last element is considered as which element? Pivot element. Sir, what is the purpose of this pivot element? You have to arrange the elements present in this list in such a way that the elements which are less than this pivot element will comes under one category, and the elements greater than pivot element will comes under another category. Sir, take 5. Is it greater than 3? Yes. Take 4. Is it less than 3? No. Sir, take 2. Is it less than 3? Yes. So 2 will come first. 6, is it less than 3? No. Sir, 1, is it less than 3? Yes. So 2, 1 will come after that 3 and remaining elements like 5, 4, 6. So from this element gets sorted. Now, which technique I applied? Try to apply same for this left list as well as right list. Here 1 will become pivot element. Is 2 is less than 1? No. So 1 will come because there is no elements lesser than 1, and 2 will come here. So 1 is the pivot element get sorted. Then apply the same principle. Since here we have only one element is there, so automatically it is going to be get sorted. So now you have to apply this technique here. 6 will become pivot element. The elements which are less than 6 will comes under left side, and greater than pivot element will comes under right side. Then take 4 as the pivot element. Sir, is 5 is less than 4? No. So 4 will come here, 5 will come here, and it is sorted. Now since only one element is there, so 1, 2, 3, 4, 5, 6 is the output. Have you observed? Based on pivot element, it is working. Sir, is that a pivot element is always a last element? No, sir. It is not always a last element. You can take either first element or last element or middle element or any location you can select. That means random locations also you can select and you can do that. Okay. It is a single function, sir. Like merge sort, we don't have two techniques. We have a single function that will do recursively this process. Okay. So if you have 10 elements, first we are dividing into two parts. Then again two parts like that. But don't worry, I will take one example along with the code and I will demonstrate. Sir, is the concept of this quick sort, is it clear?
Yes.
Right. So now we need to see the implementation of this program. Okay. So here I'm going to take one function called quicksort. One function called quicksort. Sir, how many elements it is going to take? It will take a list L and then low value and then high value. Sir, if the value of low is less than, or if the value of high is less than or equal to low, observe carefully, I'm taking less than or equal to. That means return. Otherwise, so select the pivot element which is nothing but L of low, and try to give the starting location which is nothing but low. Try to provide ending location which is nothing but high value. So in between this we have to do that division. Sir, let us take parallelly one example so that you people will get clarity. Sir, I am taking a big example, so don't get confused. Definitely you can able to understand. Okay, maybe up to certain parts I will explain. Rest of the things you can able to practice with your time, sir. Okay, so just have a look once. Sir, here I am taking the elements like sir 4, next element is 6, Okay, next element is 1. So 9, and then 2, and then 7, and then 3, and then 8, and then 5. Like this I am taking. Coming to the locations, sir, 0, 1, 2, 3, 4, 5. So 6, 7, 8. Now observe carefully what will happen. Here we are checking. Sir, what is the function call? List is there. Low value is 0. High value is nothing but which, sir? 8 is the high value. Is high is less than low? No. Pivot element will become L of low. Sir, here I have taken the first element as a pivot element. But in the example I told the last element, anything you can take. Let it be high. Sir, now which element is a pivot element? This element will become pivot element. Now observe carefully. Sir, starting location is nothing but a 0. Pivot element is nothing but a 5. Okay, ending location value is nothing but 8. Like this we have. So observe these words. Pivot element is 5, starting location is 0, ending location is 8. Okay. Now I am going to apply the technique. What is that technique? Sir, while the value of low is less than high. Sir, is the value of low is less than high? Yes. Then I'm going to check while L of low is less than or equal to pivot element and your low value is less than high. So then I'm going to take low is equal to low plus 1. So while L of high, okay, is greater than, okay, so it is so greater than pivot element, okay, and your low value is less than or equal to high value. Just I am taking high is equal to high minus 1. Sir, what is this technique? Observe carefully. Sir, what is the first time low value? It is nothing but 0. So is L of 0, L of 0 means what? 4. Is it less than or equal to pivot element? Yes. So that means no need to disturb this value. Then since it is a while loop, low value will become this one. This one will become low value. Sir, is low value, this is the low value now. Sir, is this low value is less than or equal to pivot element? No, sir. That means this while loop is failed. Coming to this while loop, L of high. Sir, what is the high value? It is nothing but 8, right? Sir, L of high means what? 5. Sir, is that 5 is greater than pivot element? What is a pivot element? Sir, 5 only. Something is wrong here. Yeah, L of high value is nothing but 8 only. So in the 8th location, which element is there? 5. Is it greater than pivot element 5? Yes, condition is false. This loop is also won't work. Okay. Next, it will come out from this. And we are checking. Sir, is the value of low, is it less than high? Sir, is the value of low is less than high? Yes, because low is pointing at first location and high is pointing at 8th location. It is less than only. Sir, if it is less than, what we have to do is, I am swapping L of high, okay, with L of low. That is not correct actually, I think so. Okay, we will see. Is equal to L of low, comma, I am taking L of high. Yes, low and then high values we are changing. Okay, that means what? Sir, do you know this 6 will come? Okay, this 6 will come here. Okay, and this 5 we are going to move here. Okay, so this is nothing but what we have.
Sir, in Quicksort we are doing swapping, sir. Is it right?
Yeah, it is swapping only. Yeah, right. I think we should not compare the last element. We should
And
not
here we
compare.
are here we are using means we are dividing first array into two sub array. Then we are comparing that element, sir.
Yes. No,
But
we are not dividing. Where we are dividing? we are taking the first element, we are comparing with the pivot element. If it is greater than this, I mean, if it is less than pivot element, we are not changing this position. Okay. And second element we have taken, since this element is less than 5 means no, that's why this is wrong place. So up to this, okay, in between this we have to get a 5. In the diagram you can see, so I explained in the diagram, right? You can see the elements which are available in the less than 5, so it should move to the right. Like that we have to do that swapping process. I will explain. I think here um, so better to take here less than or equal to. So here greater than or equal to I will take, and here less than or equal to. So here less than or equal to, not required. Here also I think less than or equal to is not required. Okay, let it be. Now you can see. Sir, again I'm starting from the beginning. Just have a look once, you will get more clarity now. Yeah. Now see, I'm going to cover with some colors. Sir, initially this is nothing but low and this is nothing but high. Sir, is low value is less than high? Observe the indexes. Yes. Then while L of low, which is nothing but 4, is it less than pivot element? What is a pivot element? 5, sir. Is 4 is less than 5? Yes, condition is true. Okay. Then low will become low plus 1. That means now this low value will become this one. So check the condition again. Is L of low 6? Is it less than pivot element? Definitely no. So this while loop got failed. It is coming to the next while. So L of high. What is a L of high? High value is 5. Sir, is 5 is greater than or equal to 5? Yes. Is low value is less than high? Yes. Then high will become high minus 1. Now this is not your high value. This will become your high value. Pivot element is not changed. Now repeat this process. L of high, which is nothing but 8. Is it greater than or equal to pivot element? Yes. Then high will become high minus 1. Sir, now what will happen? What is the element available at L of high, which is nothing but 3? Is 3 is greater than or equal to 5? Definitely not. That means what? Up to this, the elements are less than 5, and up to this, the elements are greater than 5. Have you observed? This process we captured. Now, after this, what I am doing is, sir, these two loops got failed. This loop failed, this loop failed. Is low value is less than high? Yes. Now, can you please interchange high and then low positional values? This is the low value, right? So this we have to move to the high, and this is the high value, right? This we have to move to the low. Sir, now observe what will happen. Please observe what will happen. Sir, second time the loop is going to run. Since it is a loop, again, sir, is low value, which is nothing but 1. Is it less than 6? Yes. Continue the process. L of low, which element is there? Sir, which element is there? 3. Is it less than pivot element? Pivot element is fixed. Is it less than 5? Yes. Then low value is also less than. So low is equal to low plus 1. Sir, which one will become low value now? This one. Now apply the same technique. Now observe. Sir, is L of low, which value is there? 1. Is it less than 5? Yes, condition true. That means low value is less than or equal to high value. Again, we have to change here. Now, which element is there in L of low? 9. Is it less than 5? Definitely not. That means 4, 3, 1 are in correct position. Now, go to the right side. Sir, high value, L of high. Which element is there? 6. Is it greater than or equal to pivot element? Yes. That means high will become high minus 1. Sir, now just get this high here. What is the next element that we have? 7. Is it greater than or equal to 5? Yes. That means get this element here. Okay. Sir, now what is the next comparison? Is 2 is greater than or equal to 5? Condition not satisfied. This while loop completed, this while loop. Is low value is less than high? Yes, right. Then what we have to do? Interchange the positions. That means, so this 9 is going to come here, and in this place 2 will come. Now observe carefully. This process again it is going to be repeated. Sir, what will happen now? So take low value 3. Is it less than high? Yes. Then L of low, which is nothing but 2. Is it less than pivot element? Yes. Low will become low plus 1. Sir, your low is pointing to this particular location. Now take the element, sir, L of low, which is nothing but 9. Is it less than 5? Condition not satisfied. Go to another loop. Sir, L of high, which is nothing but 9. Is it greater than or equal to pivot element? Yes. Is low value 4? Is it less than or equal to high? No. Okay. That means what? The conditions are not satisfied. That's all. This is nothing but the first part what it is going to take. Okay. Sir, please confirm. Is this concept is clear up to this whatever I covered? Sir, from this, what is the conclusion? Very simple. If you think logically, the elements, so 4, 3, 1, 2, are you seeing? These are lesser than 5. And the elements 9, 7, 6, 8, these are greater than these elements. Sir, got the logic? Please confirm. Sir, please confirm everyone. Is the concept is clear?
Yes, sir.
Now the while loop is going to fail. We will come out from the while loop. We will come out from the while loop. After this, I am going to change L of high, comma, L of start is equal to, so L of start, comma, L of high. I am going to change these positions. Which positions? Sir, high value is nothing but which location? Fourth location. In fourth location, what element is there? That fourth location, start means what? Sir, not a start. I think we have to take end, because we are taking the last element as the pivot element, right? That ending position, and then this particular high value, these two I am going to interchange. So means what? Sir, this 9 is there, right? So this 9 will go here. Okay. Okay. And this 5 will come here. So this 5 will come here, this 9 will go here. So indirectly, just for your understanding, I am drawing like this. Now it is clear, right? Perfectly working. So this is the pivot element, less than pivot element, greater than pivot element. That's all. Sir, can I repeat this process? Yes. How you can repeat? I am calling the same quicksort function by passing the same list, and I am going to take the starting position as a 0. And what about ending position? Can I take high minus 1? Because starting value is 0, high is pointing at fourth location, 4 minus 1 means 3. Now apply the principle for 4, 3, 1, 2. Similarly, can you please recursively call one more time by passing L comma, and I am taking, so high plus 1 comma end. What is a high plus 1? 4 plus 1, 5 to the ending 8. Can you apply this process? So this process is going to be repeatedly done. That's all, sir. Let us take the same elements and check whether we are getting or not. So list is I am taking, so 4, 3. Okay. I think this is after swapping, sir. 4, 6. So 1, 9, 2, 7. Okay. 2, 7. So 3, 8, 5. Something like this I am giving. So before sorting, what will be the case? And then I am going to call quicksort by passing the list 0 comma length of the list minus 1. So after this, I am going to print the list. Let us cross check really is that a quicksort is applied or clear.
Yes,
Sir, clear everyone, please confirm.
Yes.
So this is nothing but what we have about this quicksort. With this sorting algorithms and divide and conquer got completed. Sir, tomorrow I will start searching algorithms In the searching algorithms, around 5 to 6 cases are there. I will explain all those things. Okay. Sir, actually this week again I am going to take so 2 offs. Why? Because some relatives marriages are there. Okay, that's why maybe I'm going to take 2 days off. I will inform you, but those 2 days compensation I will provide. This weekend we have a class in the evening time, sir. Maybe around 5 to 7 like that. I will take 2 hours session. I will take this Saturday and Sunday. Okay, maximum we are going to cover this linked list data structure in that time period. Okay, so please make your time available.
Sir, can you please tell me a brief introduction about where we can use all the sorting algorithm? Which I mean to say that where I can apply insertion sort, where I can apply bubble sort, where I can apply quick sort. Means
That I will explain. I will explain definitely. At the end of sorting algorithms, I will cover. So what is the difference between which sorting we can apply on what time period? I will explain. Depending on the input, it is going to vary. Depending on the situation, we have to change. I will explain. Don't worry. Comparison between the sorting algorithms, definitely I will cover. Okay.
okay.
Right. Right, sir. Thank you. See you
Thank you.
tomorrow's class.